looking at further mechanics, further maths, May June 2023, paper 3, variance 2, mechanics paper. The first question is Hooke's law. The question is one end of a light elastic string of natural length. The natural length of the string is A, and the modulus of elasticity. The modulus of elasticity is 3 mg. That's the modulus of elasticity, 3 mg. Is attached to a fixed point O. So the length, the elastic string is attached to a fixed point O. So the other end is attached to a particle P of mass m. Let's look at it. Now this is the string. There's a point that is fixed. So there's a point that is fixed, which is O. The other end is attached to a mass m. A particle P is attached. The particle P has a mass of m. Remember that the length of this string is A. Now, the string hangs with P vertically below O. This is P vertically below O. The particle P is pulled vertically downward. So the extension of the string is 2A. Particle P is pulled vertically downward. So the extension, the extra length is 2A. This is the extension, is 2A. The extra length is the extension, which means the new length will now be 3A. That's the new length. That's from O, from this point. The new length is from O down to this point. That's 3A. Now the question asks us to find the speed of P when the distance is 3A below O. The speed when the distance is 3A below O. Now initially, remember that initially, look at the statement, the particle P is then released from rest. Initially is at rest, obviously because the natural length was A, so it wasn't moving. Before you attach the mass, it wasn't moving. Kinetic energy was 0. Before we attach the mass, potential energy, no increase in height. But the natural elastic potential energy of that string, the energy the string naturally have, the formula for elastic potential energy is lambda x squared over 2L. So the elastic potential energy of the string, lambda is elastic, that's the modulus of elasticity, which is 3 mg. X is the extension, which is 2A all squared, all over 2L. L is original length. This is the natural elastic potential energy of the string. Now, this is the initial one. Finally, when you stretch it from P from P downward, when you stretch the mass from P downward, so it moves with the velocity. So kinetic energy is half mv squared. I don't know the velocity. Potential energy at that point is mgh. The question asks us to find the speed at a distance 3a below O. Now, if you look at it critically, within A, from here to here, within A, 3 over 4a falls, 3 over 4a is like 0.75a, which falls within A. If you look at it, within A, there is no potential energy yet within A, because there is no movement within A. We start experiencing potential energy when this particle was pulled down with an extension of 2a. So the question asks us to find the speed when the distance is 3a below O. So 3a below O, potential energy is not possible. 3 over 4a below O. So potential energy is only possible when it's stretched down below A, more than A. So we have to amalgamate in this sense. The height, so where we experience potential energy is within 3A. Within 3A, after A downward, potential energy, the question said below O. Below O can also be from here down to this place. It's still below O. So potential energy 3 over 4A below O can be 3A minus 3 over 4A. You can have a potential energy in between that range below O, but there can be potential energy within A. Potential energy is only possible after A. So so that's the reason I consider potential energy within 3A. And the distance is 3 over 4 below O. That's why I subtracted 3A minus 3 over 4A. So that's the potential energy 3 over 4 below O. The question never mentioned the body will turn back, so no elastic potential energy at that point. So using the principle of conservation of energy, or work energy principle, initial energy must equal to final energy. Initial energy, this plus this for elastic potential energy, we have 3mg times 4a squared all over 2a. Final energy, we have kinetic energy half mv squared plus potential energy mg 3a minus 3a minus 3a over 4, that gives us 9 over 4a. So the question asks us to find the speed. From here we have this a, cancel this a. At the end of the day, 2 here 1, 2 here is 2. So we have 6 mg at this point, equal to, is this 6 mga? Yeah, 6 mga equal to half mv squared. That's mv squared over 2 plus this one gives us 9 mga over 4. When you collect the like term, that's 6 mga minus 9 over 4 mga equal to mv squared over 2. So 6 mga minus 9 over 4 mga, that's 24 minus 9, that's 15 over 4 mga equal to mv squared over 2. Mass cancel mass. So at the end of the day, 4v squared equal to 30 ga, which gives us 2v squared equal to 15 ga. So v, the speed, is square root of 15 over 2 ag, which is also the same thing as 2.74 square root of ag, meter per second. That's the speed at a distance 3/4a below O. Let's see the next one. Find the initial acceleration of P when it is released from rest. When the body is released from rest, the weight is pulled downward. So there's resultant force. Resultant force will be tension minus the weight. So the weight is downward. Resultant force is always stretching in positive outside. That's toward the positive direction. From Newton's second law of motion, resultant force is mass times the acceleration. Tension, in this concept, elasticity, tension is lambda x over L. Weight is mg. So from here we have ma equal to lambda is 3mg, extension as we discussed is 2a, length is a, minus mg. So a cancel a. So we have ma. This one is acceleration anyway. It's not the a in the question. Ma equal, this gives us 6 mg minus mg. Mass times acceleration. This one gives us 5 mg. Mass cancel mass. So acceleration is 5g and g is 10, which can be 50 meter per second square. That's the acceleration. That's the first question. Now the second question. Obliged collision. We have a particle P of mass m moving with a speed u on the fixed horizontal surface. It's moving with a speed u on a smooth horizontal surface. It collides at an angle alpha, as you can see, with a fixed smooth surface vertical barrier. After collision, it's moving at an angle. So the velocity is moving at an angle. Let's resolve it horizontal. The horizontal velocity in this case, this is adjacent over hypotenuse. It give us opposite over hypotenuse. This one will give us u sine alpha. Vertical component of that velocity will give us u cos alpha. It collides at an angle alpha with a fixed smooth vertical barrier. After the collision, P moves, that's final velocity, at an angle theta. After collision, P moves at an angle theta with the barrier where tan theta. This after collision. Let's resolve that too. Let's resolve it. Opposite over hypotenuse. This will give us toward parallel. This will give us b sine theta, and this perpendicular to the wall. While vertical, when we resolve it vertically, it's going to give us b cos theta. Now, it said where tan theta is equal to half, the coefficient of substitution between P and barrier is E. Particle P loses 20% of its kinetic energy. Loses 20% of its kinetic energy. So it means that particle P, which means the final kinetic energy, when something loses 20%, what it means? 80%. So final kinetic energy is 80% of its initial kinetic energy. So 0 comes to 0. So which means final kinetic energy is 4/5 of its initial kinetic energy. So final kinetic energy is half mv squared. 4/5. Initial is half mu squared. So take note of this. I'm coming back there. Take note of that. So now the question asks us to find the value of E. Now the first thing we'll do is this. The motion is horizontal. So the motion is the one perpendicular to the wall. So perpendicular to the wall, perpendicular to wall, we have u sine alpha and v sine theta. Remember restitution, coefficient of restitution E is speed of separation over speed of approach. Separation is final velocity, approach is u. That's the formula for coefficient of restitution. Speed of separation over speed of what? Approach. Take note of that. So in this case, now final perpendicular to the wall, final is b sine theta, right? B sine theta. Initial is u sine alpha. So in this case, b sine theta will be equal to eu sine alpha. That's where the motion. Now parallel to the wall, we have u. The final is v cos theta equal to u cos alpha. That's parallel to the wall, equation 2. Now we have two equations. So divide both equations. Indirectly I'm trying to use momentum, as in v final equal to initial, by resolving perpendicular and parallel. So we have two equations. Divide both of them. Let's divide equation 1 by 2. I'm doing that because I want to get something of tan. So we have v sine theta over v cos theta equal to eu sine alpha over u cos alpha. So v cancel v. At the end of the day, we have tan theta equal to u cancel u. We have tan theta equal to e tan alpha. Remember from the question, there's a condition, tan theta equal to half. Since tan theta is half, so e tan alpha is equal to 1 over 2. So from here, e will be 1 over 2 tan alpha, equation 3. Remember, okay, I'm trying to manage the space. Remember the question, the condition that said particle P loses 20% of its kinetic energy as a result of collision. I got an expression after that time, half mv squared equal to 4 over 5 times half mu squared. Is it? You can see. Now, let me find the initial velocity. Now, initial velocity, we have u sine alpha, we have u cos alpha, the perpendicular initial velocity and the parallel initial velocity. So, to find, since we have two initial velocity, perpendicular and final, I need to find the magnitude of the initial velocity. Magnitude of initial velocity is like resultant to be u squared equal to u squared, that's in Pythagoras theorem, u squared equal to u squared sine square alpha plus u squared cos square alpha. And we call that u sine alpha is equal to look at it, we call that from here v sine theta equal to eu sine alpha. So let me find from there, u sine alpha will be equal to v sine theta over e. Now we have we can find sine theta from tan theta. If tan theta is half, that's opposite over adjacent is 1 over 2. I think the hypotenuse will be root 5. So we can get sine theta. Sine theta is 1 over root 5 in that case. So from here, so u sine alpha will be equal to v sine theta. And sine theta is 1 over root 5, which is root 5 over 5. Equation 4. This is my u sine alpha. And also we call also parallel to the wall v cos theta equal to u cos alpha. We call that v cos theta equal where is it? V cos theta equal u cos alpha equal u cos alpha. So from here we have, what's cos theta? Adjacent over hypotenuse. I think the adjacent is 2. Yeah, hypotenuse is root 5. So we have 2 over root 5 equal to u cos alpha, which is the same thing as 2 root 5 when you rationalize over 5b equal to u cos alpha. This is equation 5. Now substitute equation 4 and 5 in the magnitude of velocity, the initial velocity before collision, in magnitude of velocity. So let's substitute it, So u square will be, now this is u square sine alpha, and u sine alpha is root 5v over 5e all square, plus u cos alpha is 2 root 5 over 5, I think b all square. At the end of the day, our u square will give us v square over 5e square when you simplify, plus 4b square over 5. These are u square. Then substitute the u square into the kinetic energy. We call that the particle loses 80% of the kinetic energy. At the end of the day, we resulted into half mv square equal to 4 over 5 times half mu square. And u square is this, is v square into bracket 1 over 5e square plus 4 over 5. So from here, v square cancel v square, m cancel m, in fact half cancel half. So what we have here is 1 equal to 4 over 5 into bracket 1 over 5e square plus 4 over 5. So let's simplify. Now simplifying, we're going to have something like this. The 1 over 5 is also common there. If 1 over 5 is common there, so most likely you have 1 equal 4 over 5 times 1 over 5 into bracket 1 over e square plus 4. So from here, I can make 4 plus 1 over e squared the subject of the formula. So that will be 1 over 4 over 25. So 4 plus 1 over e squared will equal to 25 over 4. So 1 over e squared is 25 over 4 minus 4. So So 1 over e squared, 25 over 4 minus 4 will give us 9 over 4. So e squared is 4 over 9. E will be plus or minus 2 over 3. So e is 2 over 3, the positive one. So that's the answer, 2 over 3. Let's see the next question. Number 3. Okay. A particle P, this is vertical circular motion, VCM. A particle P of mass m is attached to one end of a light inextensible string. The other end of the string is attached to a fixed point O. Okay. The particle is held at a point A such that they held the particle such that OA makes an angle of theta. So they held the particle at an angle, okay, with the downward vertical through O, with the same tau. The particle is projected perpendicular to OA. Okay, the particle is projected perpendicular to OA, upward direction with speed u, circular motion. It then starts to move along the circular path in the vertical plane. The string slack when P is at B. When P is at B is slack. The angle at which the string slack is 90 degrees. And at that point, and the speed of P at that point is this. Find the value of sine theta. So let's draw the diagram. Now, okay. Let me draw the diagram here. Okay, I think it's big enough to express myself. Now, if you remember, the question said that the particle is at a fixed point O. Let's say this is O. This is O. So the particle, so we have something like this. This is a particle held here. This is the particle. This is A. So where OA makes an angle theta with downward. This is the angle. This is O. Angle theta with downward. So let's list the forces on A. You know, is inclined at an angle theta. Here is weight. Here is the weight, mg. You know, it just when you are putting down the forces, just think as if you are doing inclined plane. This space is mg cos theta. Like this is mg sin theta, which is parallel to this mg sin theta. Now remember the question said that this is P is projected perpendicular to OA. You know, downward is mg sin theta, but it's projected perpendicular to OA like this. Now, so the question now set further that the string goes slack when P is at B. Now the question is, where is B? Angle AOB is 90. Okay, now the string cannot be 90 at this point. It's not possible. This angle cannot be 90. Let's say this at this point. Let's assume that it said AOB. Let me put this point B. AOB. So it's 90. let's say it's 90 at this point. What happened when the string is at 90? It said the string goes slack. First, let me resolve the forces again. This is the weight, mg. Now, at this point, you know, mg cos theta and mg sin theta are always perpendicular to each other. So if this is mg sin theta, mg cos theta is there. This is the weight, mg. This is theta in between them at this point. At B, the question said the string goes slack at B. At B, it goes slack, tension is equal to 0. At B, tension is equal to 0. And the question said, so at that point, when the tension is 0 at B, so the only force available is mg sin theta. So the mg sin theta will be the only one to provide centripetal force. Remember when you are defining centripetal acceleration is an acceleration in which is perpendicular to the direction of velocity. So at B, since the string is slack at B, so T is equal to 0, tension does not exist at B. So the only force bringing the particle toward the center will be mg sin theta. So from there, we have mg sin theta equal to centripetal force mv squared over r. So m cancel m. So and at B we have g sin theta. The speed at that point is square root of 4 over 5 ag all squared. That's the speed at that point over the radius. So in this case, what's the radius? The radius is a. When you check it, the length of the string is a all over a. So from here we have g sin theta equal to square cancel square root. So we have 4 over 5 ag all over 5. A cancel all over a, A cancel a, g cancel g. At the end of the day, what's sin theta? And sin theta will be 4 over 5. That's the answer. That's sin theta, 4 over 5. Okay, I believe it's clear. Let's move to the next question. Now, next question. It said find in terms of M and G the tension in the string when P is at A. Now, we have two motion in this question. Motion from A to B, that's the motion. So at A, this is a string, it's stretching out, the tension is stretching out. So at A, let me check, we have enough space. At A, what happened at A? The resultant force at A is tension minus mg cos theta. So, and tension minus mg cos theta will give us mv squared over r. Will give us mv squared over r. And the velocity they use in projecting the body at A. The question said at A, when they projected the body at A, they project with the speed of u. Can you see? They project with the speed of u. So we have t minus mg cos theta equal to mu squared over radius a. That's equation 1. At the same time at A, the kinetic energy at that point is half mv squared. That's half mu squared. Potential energy at A is below zero, so it's negative. Potential energy radially, that's minus mgh. mgh here in this case, h is a cos theta. So that's the potential energy at A. So total energy at A will be half m u squared minus mga cos theta. That's the total energy at A. Now at B, the particle now is at B. The particle is at B. So what happened at B? The particle has gained height. The particle has gained height at B. So the particle has gained height at B, from here, from A to B, the particle has gained height. Look at the height. So OB is the radius A, and the string is at an angle theta with the horizontal. So let's get the height. So sine theta is the opposite over hypotenuse. From that diagram, sine theta is h over A. So h in this case is what? A sine theta. So at B, potential energy is mgh, and h here is what? A sine theta. We are still at B. The kinetic energy is half mv squared. And remember, the question said that the velocity at B is square root of 4 over 5 ag. Without the square cancels square root. So kinetic energy at B is half m 4 over 5 ag. So the kinetic energy at B is half m 4 over 5 ag. So that will be 4m. I don't want to cancel yet. Ag over 10. So total energy at B with potential energy at B plus the kinetic energy at B. If you remember, if you see what I did, potential energy at B is positive, while at A is negative because A is below zero, B is above zero. So total energy at B will be what the potential energy at B, that's mg A sine theta. Kinetic energy, the kinetic energy at B is 4 over 10 mag. So using the principle of conservation of energy, POCO, total energy at A will equal to total energy at B. What is total energy at A? That's half mu squared minus mga sine theta. What is total energy at B? The total energy at B is half, let's see, mga sine theta plus 4 over 5, 4 over 10 mag. So collect the like stem. So we have half mu squared, probably minus 4 over 10 mag equal mga sine theta plus, no, this one is cos, mga sine theta plus mga cos theta. So from here, half is common. So what do you have here? Mu squared minus 4 over 5 mag equal mga is common here. We have sine theta plus cos theta. So divide both sides, multiply both sides by 2. So 2 cancel 2. So what do you have here? We have mu squared minus 4 over 5 MAG equal to MGA. Remember from the first question, sine theta, we got sine theta as 4 over 5. Sine theta is 4 over 5. If sine theta is 4 over 5, cos theta should be 3 over 5, as in sine theta opposite over hypotenuse. Here will be 3. Cos theta is 3 over 5. So at the end of the day, we have mu squared minus 4 over 5 MAG equal to 4 over 5 plus 3 over 5. I think we have 7 over 5. We have 7 over 5 MGA. So from here, let me check the space. So from here, we have mu squared equal to 7 over 5 MGAG plus 4 over 5 MAG. I remember at A we have T minus mg cos theta, equation 1 equal to mu squared over A. So which means that at that point we have mu squared equal to 7 plus 4. What do you have at 7 plus 4? So from here, oh, I've omitted 2. I've omitted 2. So we have there's a 2 here, if you remember. When I multiply both sides by 2, there's a 2 here. So at the end of the day, I have mu squared minus 4 over 5 MAG equal to, when you do this, we're going to have 14 over 5 MAG. So mu squared will be, collect the like term, I think you're going to have 18 over 5 MAG. Since at A, remember we have T minus mg cos theta equal to mu squared over A. And you know that cos theta is 3 over 5 equal to mu squared over A. So we're going to have 3 mg over 5 equal to mu squared over A. And what's mu squared? Mu squared is 18 over 5 mag. 18 over 5 mag, that's mu squared all over A. So A cancel A. T minus 3 mg over 5 will be equal to 18 over 5 mg. At the end of the day, T will be 18 over 5 mg plus 3 mg over 5. So T will be 21 mg over 5. Is the value of the tension they asked us to find in terms of M and G. I believe it's clear. Questions is entertained in the comment section. Let's move to number 4. Okay, now we have an object. It's formed from a solid hemisphere of radius 2a and a solid cylinder of radius a. Look at the hemisphere radius 2a, cylinder radius a, and height d of the cylinder. The height of the cylinder is d. The hemisphere and the cylinder are made of the same material. The same material. Same material means same density. The cylinder is attached to the plane. the cylinder is attached to the plane. You can see the plane of the face of hemisphere. The line OC forms diameter of the base of the cylinder, as you can see, where C is the center of the plane, face of the hemisphere, and O is common to both circumferences. O is common to both circumferences. It's key. An interesting question. Where C is the center of the plane of hemisphere, and O is the common base of the circumferences. Relative to axis O, parallel and perpendicular to OC. The center of mass of object is by X and by Y. Show that the center of X about X horizontal is this, and find the expression in terms of A for by Y. Or the formula for center of mass. There will be summation of mass multiplied by center of mass all over total mass. So where mass is density times volume. Mass is density times, because density is mass over volume. Mass is density times volume. So in this case, the volume is the same, is uniform. So at the end of the day, this is what we have at the end of the day. The center of mass in this case will be volume multiplied by position of the center of mass all over summation of volume. This is what we have. This is what we're going to use. Now, first, now from here to here is A for the cylinder. The center of mass X, the center for the X axis for cylinder is A. The center of mass for Y axis for cylinder, the center of mass for that one. So that one will be, for Y axis, is the midpoint of diameter, that's D over 2. So it's somewhere here, A and D over 2. That's for cylinder. And for hemisphere, the center of mass for hemisphere, so for X, for the horizontal axis, for the X axis, hemisphere, from here to here is 2A. That's the center. And center of mass for hemisphere for Y axis is 3 over 8 radius. Is on the MS9. Let me show you. Look at it. Look at it here. The center of mass for hemisphere is 3 over 8 radius from center. It's 3 over 8 radius from center. So you're going to have, so it's 3 over 8. Now it's going down because the hemisphere is facing up. So that will be the y-axis, the center of mass for y-axis for hemisphere is negative because it's going down. Assuming it's like this, the center of mass from the center will be positive. So now, to find the horizontal center of mass, from the formula, summation of volume and the position of the center of mass over total volume. So it's going to be volume of the cylinder multiplied by the horizontal center of mass for cylinder plus volume of hemisphere H multiplied by horizontal position of center of mass for hemisphere all over total volume, volume of the cylinder plus volume of the hemisphere. So from there Now, what's the volume of the cylinder? Is pi r square h. In this case, the radius of the cylinder is a. So the radius of the cylinder is h. Pi r square h. Let's check h, the height of the cylinder. The height of cylinder in the here is d. So radius is a multiplied by what the center of mass for cylinder is a, plus volume of hemisphere is 2/3 pi r square h. In this question, the radius of hemisphere is 2a multiplied by what the center of mass, horizontal position from hemisphere is 2a, all over the total volume. That will be pi r square h plus 2/3 pi r cube. Now let's simplify. So from here we have from this point we have pi. This will give us pi a cube d plus 2/3 pi. This one will give us 8a cube multiplied by 2a over the bottom. We also give us something like pi a squared d plus 2/3 pi 8a cube. So let's simplify. So from the top we can have 3 pi a squared d. Let me check space. We have one space. 3 pi a squared d plus 2 pi times 8a cube times 2a over 3. That's from the top. All over the bottom two, we can have 3 pi a squared d plus 2 pi times 8a cube over 3. So 3 cancel 3. At the end of the day, we have 3 pi a squared d plus 2 times 8 is 16. 16 times 2 is 32. 32 pi a raised to the power 4 all over 3 pi a squared d plus 16 pi a cube. So we have to find that, show that this, and also find the vertical center of mass. Okay. Now, what is common here? I think pi a cube is common. Let me see. What is common here? Pi a square is common there. So when you bring it out, what you meant here? Let's see. So we have, when you bring pi square, we have 3d plus, I think here is 32a square all over bottom. I think when you factorize pi a square 2, yeah, we have 3d plus 16a left here. So this cancels this. At the end of the day, I think we have 32a square plus 3d, 32a square plus 3ad. Okay, I think I've omitted something. This is cube. How come it turned to square? So it's cube. It's cube. This is, let me turn it properly. This is Q. So at the end of the day, there's still A here. So at the end of the day, we get the proof. So the horizontal center of mass is 3AD plus 32A squared. 3AD plus 32A squared over 3D plus 16A. Yeah, that is what we are asked to prove. The other one, we have to also find, in terms of A and D, the expression for Y. So for Y, it will be volume of the cylinder multiplied by volume of cylinder multiplied by its vertical center of mass plus volume of hemisphere multiplied by its vertical center of mass all over total volume. At the end of the day, I need to manage my space. Volume of cylinder, we know, is pi r square h by a square d. The vertical center of mass for cylinder is half d, plus volume of hemisphere is 2/3 pi a cube. The vertical center of mass is minus 3/8 radius. Please permit me, all over the total volume. That's pi a square d plus 2/3 by 2a cube. So by the time you factorize this, you're going to arrive at something like this: 3 into bracket d squared minus 8a squared over 2 into bracket 16a plus 3d. Don't forget, this is minus 3/8 now. If you simplify, you're going to get this. That's the first question. The next one, the object is placed on a rough inclined horizontal, inclined to the horizontal at an angle of sine theta equal to 1/6. The object is in equilibrium with CO. The object is in equilibrium with CO. This is key. The object is in equilibrium with CO horizontal, where CO lies in the vertical plane through a line of the greatest slope. Find D in terms of A. This is what the question is trying to do. This is the incline. Please pay attention to this. I need more space. This is incline. The incline plane. This is theta. Now, this is how it will be. The object is placed. Of course, remember this is the hemisphere. From the diagram, this is a cylinder. We're going to have, from here to here is 2a. This is 2a. The other one is 2a. This cylinder. Now don't forget that from here, let me change the marker. Now in this case, at this point, you need to be very careful. The object will be tangential with this point at this case. To be tangential with this point, with the edge. Remember that this is a horizontal center of mass. At this point, the vertical will tilt toward this position. The vertical will tilt toward that position. Like I said, this will be tangential. I need to draw it clearly. Okay, so from here, from here to here is the horizontal center of mass. Now, remember that the center of mass for the sphere is around here. Is around here. And from here to here, at this point, when this is tilting, if you pay attention, it will be tangential with this sphere. Now, the new center of mass, which at that angle will come toward this point. Now, what's from here to here? From here to here, if from here to here, if from here to here is by x, and everything here is 2a, so the remaining small space here will be 2a minus x. This, like I said, this angle theta, here will be angle theta. This side and this side, this side and this side will be, okay, sorry. Okay, so from here, like I said this line here with tangential with the sphere, and the same thing from here, that will be the same, tangential. So if here is theta, here is theta, alternate angle, here is also theta. Remember that from here to here is 2a. At the end of the day, this is what is formed. Here is 2a. This is the other side here. This side is 2a. Here is 2a minus x, and this is the angle. Okay, now let me make it clear. At the point of tilting, this place, this line will be tangential to this place. Be tangential this line. So from here to here is 2a, which is the same thing as here, 2a. So this place is our x by x. So the remaining place will be 2a minus x. So form a line, a triangle. Hold on, let me make it bigger a bit. Let me make it bigger a bit. It's an interesting question that needs a serious attention. Let me make it bigger so it can be clear. I'll make it of different color. Now, this is it. At that point, the cylinder and this edge will be tangential at that point. So this is it. Now, let's go from here to here. This side, from this side, from here to here is our bar X. So somewhere here is bar X. Somewhere here is bar X. Bigger. So it's tilting. This will pass here. Oh, sorry for my diagram. Let's be very careful. Okay. This one will be clear. Let me draw the line. From here to here. From here to here is the horizontal center of mass. So it's tilting. So we have there'll be a line here like this. This one is already tangential with the sphere. This is bar X, and everything here is 2A. So the remaining small place here with 2A minus X. Now this side will be parallel to this side. So from here, form an angle. So this is the angle. This place is 2A minus X. This is 2A. Now this is the line that joined them together. Here is theta. Here is theta. Here is theta. Alternatively, here is theta. So now this is a triangle. Please manage my diagram. From here, from this triangle, tan theta will be 2A minus X over 2A. I'll do this question. I'll do it in two ways. Please, the masking gave us a clue that sine theta is equal to 1/6. They did that because they want you to avoid stress. This is an approximated value. I'll show you. It's correct, but both methods I'll show you is an approximated value. Let's base on this diagram. So from here, sine theta is 2A minus bar X. So let's find 2A minus bar X first. Now, what's our bar X? That's the horizontal. So let's find 2A minus center of mass of X. Let's find it first. So the center of mass of X is, I think it's 32A squared plus 3AD all over 16A plus 3D. So 2A minus X will be, that will be 2A bracket 16A plus 3D. minus 32a squared plus 3ad over 16a plus 3d. So at the end of the day, when you open your bracket, simplify, we're going to have something like this. Open your bracket and simplify, we're going to have 3ad over, is it 3ad? No, we're going to have 3d. We're going to have 3d over 32a plus 6d. 32a plus 6d. By the time you put over 2a here, this is what we have. So 3d over 32a plus 6d. Coming? Let me, no, give us with 35, not with 5. The adjacent will be with 35. So tan theta is 1 over with 35. That will be 1 with 35 is 5.9. That's tan theta. So since tan theta is 1 over 5.9, put it there. 2a minus by x over 2a, we have 3d over 32a plus 6d. Cross multiply, we have 32a plus 6d equal to 3d times 5.9, that's 7.7d. Collect the like stem. So 32a is there, 17.7d minus 6d, that's 11.7d. So d will be 32a over 11.7. So our d will be 2.74a. That will be our d. We check the mark scheme. The mark scheme gave us d to be, let me check it. The mark scheme gave us d to be 8 over 3a, which is 2.7a. Now, the clue that they gave us from the question, alternatively, you can also solve the question like this. Back to the diagram. You know, from here to here is 2a, this line. Here is 2a minus x. You know this line, let me call this A, B, C. This AC is approximately 2A. This place is also approximately 2A. Is approximately 2A. From here, AC is approximately 2A. If you check, assume a value for A and a value for by X, you see what I'm saying, that this AC, I don't have time, I don't have enough space to prove it. This AC is approximated to A. Now, from here, you can do sine theta. So from that diagram, sine theta 2 can also be 2A minus by X over 2A. If you use this and simplify, you are going to get D as 8 over 3A, which is equal to 2.7a. This is an approximated value because the mark scheme wants us to use the approximated side of AC. They don't want us to go to the stress that this line, by the time it tilted, this line is a tangent. It's going to be parallel, tangent with this sphere. That's the best way to solve it. Probably they don't want to stress the student, so they just use an approximated value. So either way, you get the answer. I'm free. You can send me an email for further proof or assistance on this question. You're welcome. It's a nice and interesting question. Let's see the next one, number 5. Okay, now a light elastic string of natural length. The natural length is A. Elastic mode of elasticity is this. Has one end attached to a fixed point O. One end is attached to a fixed point O on a smooth horizontal surface. When the particle M is attached to the free end, when the particle M is attached to the free end of the string, it moves with the speed v. It moves with the speed v horizontal with horizontal circle with center O and radius r. Center O and radius r. Remember, the original length of the string is A. So when a mass of M is attached, it moves in horizontal speed, horizontal circle with center O and radius x. Let me take that. The original length is A. When the mass of M is attached to the string, we have an extension of radius, which is x. The fact that it's moved in a horizontal circle is moved in a horizontal circle. Now, the energy in the tension, or the tension force, the force in the tension will provide the centripetal force. Now, what is tension? From Hooke's law, lambda x over L equal to centripetal force, mv squared over r. So from here, and what's our modulus of elasticity? Is lambda mg. Extension is the radius minus original length. What's the length? The length, original length is A, equal to mv squared over the radius, which is A. So from this place, let's make v squared the circular formula. So we have, when you cross multiply, m can cancel m from here. When you cross multiply, we have lambda ag x minus a equal to v square a. So at the end of the day, v square will be lambda ag, lambda ag over sorry, it should be like this. At the end of the day, we have, the radius is x. Let me change the marker to a colorful one. The radius is x, not a. mv squared over r, this is x. So m still cancel m. At the end of the day, lambda gx x minus a equal to v squared a. Make v squared the subject of the formula. So we have lambda gx x minus a all over a. This is when mass of m is attached. Now, if you check the further question, it said when the mass is 2m is attached to the free end of the string, the particle moves with the speed of half v. We're going to repeat the same thing. Now, when the mass is 2m, the velocity is half v. So the tension is still the same. The tension is still T, but the mass is down. The mass has been changed from m to 2m. So T is lambda, for the formula, lambda x over L. Lambda is modulus of elasticity, which is lambda mg. And extension in this case is, the new radius is 3 over 4x. 3 over 4x minus the original length all over a equal to centripetal force. This is when the mass is m. centripetal force mv square over r. In this case, the v is now half v. The radius is x. At the end of the day, mass cancel mass. We have lambda 3 over 4x minus a all over a, so equal to 1 over 4 v squared over x. So when you cross multiply in this situation, when you cross multiply, we have this is half mv squared over r. Oh, the radius in this case is not x. The radius when the mass is 2m is 3 over 4x. 3 over 4x, that's the radius. Is 3 over 4x. So from here, when you cross multiply, we have 1 over 4 v squared equal to 3 over 4x multiplied by lambda 3 over 4x minus a all over a. So from here, we can easily say, so okay, there's still g here. So the mass is 2, not m, it's 2m. So we still have 2 here. So we have 2 times, and there's still g here. At the end of the day, I have half v squared equal to 3 over 4 lambda gx bracket 3 over 4 lambda gx bracket 3 over 4x minus a all over a. Sorry. Oh, let me simplify it properly here. Let me simplify it properly. I want to make v squared the subject of formula in this one, so I can equate it with equation 1. So sorry. Okay. And the space is one of the issue. I'm trying to manage this small space given. Let me see. Okay. The space is lambda 3 lambda mg. Okay. Lambda mg, that's tension all over a. So which can be written as lambda mg over a bracket 3 over 4x minus a is equal to, this one is 2m v squared over 4 all over 3 over 4x. When you cross multiply, we have lambda mg over a, so multiply by into bracket 3 over 4x minus a multiply by 3 over 4x equal okay, so equal 2mv squared all over 4. So from here, I think we have 2 here 1, 2 here is 2, so mass cancel mass. So at the end of the day, I'll be left, when you cross multiply, I'll be left with 2 lambda g over a, 3 over 4x minus a multiplied by 3 over 4x equal to v squared. So 2 here 1, 2 here 2. So now v squared is equal to 3 lambda gx, 3 lambda gx over 2a bracket 3 over 4x minus a. This is the second equation. So this is the second equation. So equate equation 1 and equation 2. So equation 1 is lambda gx x minus a over a, that's equal to v squared. The other v squared is 3 lambda gx over 2a 3 over 4x minus a. Now lambda gx over a out, lambda gx over a out. What left here is x minus a equal to x minus a equal to 3 over 2 bracket 3 over 4x minus a. Simplify. Here should give us 2x minus 2a equal to 9 over 4x minus 3a. So collect the like terms. That should be 2x minus 9 over 4x equal to minus 3a plus 2a. At the end of the day, we have minus 8 minus 9 minus x over 4 equal to minus a. Minus cancel minus. X equal to 4a. I think that's what they asked us to do for. Find x in terms of a. So x is equal to 4a. Now the next question. Given that v is equal to square root of 12ag, find the value of lambda. So in this case, just use any of the equation of the velocity. Let's use equation 1. Equation 1 is v squared equal to lambda gx x minus a all over a. Now since v squared is this, substitute it there. So if v is square root of 12ag, v squared will be 12ag equal to lambda gx into bracket x minus a all over a. So and what is our x? Our x is 4a, the one we just obtained not quite long. So lambda gx, x is 4a, 4a minus a over a. So 12ag equal to lambda gx. Remember that x is 4a. 4a minus a is what? 3a over a. A cancel a. At the end of the day, we have 12ag equal to, there should be 12a g lambda. Ag cancel ag. 12 equal to 12 lambda. So lambda is 1. That's it. Number 6. Number 6 question. A particle moving in a straight line has a displacement x meter from a fixed point O on the line and velocity v. The acceleration p is given as 6v square root of v plus 9. When t is 0, x is 2, v is 72. Find the expression of v in terms of x. Find the expression of v in terms of x. By giving a model for acceleration. Acceleration is 6v square root of v plus 9. You know, this kind of question, the way we express acceleration, is related. You need to express acceleration with respect to s. with respect to x. Acceleration is the v, rate of change of velocity, and the v, the t. If I want to bring the x there, it's the same time as the v dx times the x dt. When you check it, it's the same thing. When the x cancels the x, we have the v dt. The v dt here is acceleration. Now, change in displacement over time. This is velocity multiplied by the v dx. So this is acceleration. So acceleration is also the same thing as v, the v dx. So let's put it there. So which means A is v, the v dx, equal to 6v square root of v plus 9. Let's separate the variable. Cross multiply first. V dv will be 6v square root of v plus 9 dx. When you cross multiply, v cancel v. At the end of the day, we have the v over square root of v plus 9 equal to 6 dx. Now you separated the variable, then integrate both sides. After separating the variable, integrate both sides. At the end of the day, this means 1 over square root of 9 square to raised to the power half dv equal to 6 integral of dx. Now this also means v plus 9 raised to the power minus half the v equal to integral of dx is x plus arbitrary constant c. When you integrate this, we have v plus 9 raised to the power minus half plus 1 half all over half equal to 6x plus arbitrary constant. So when you simplify this, you're going to have 2 square root of v plus 9 equal to 6x plus c. Remember the initial condition given. Let's check the condition. When x is 2, v is 72. So when x is 2, v is 72. 72 plus 9. What do we have? 72 plus 9. That should be 81. That's 81. Equal to, at that point, x is 2 plus c. 9 times 2 is 18. 18 minus 12 equal to c. C is 6. So hence, and c is 6. Hence, we have the equation will now be, hence, we have 2 v plus 9 raised to the power half equal to 6x plus 6. So which is the same thing, divide through by 2, v plus 9 raised to the power half is 3x plus 3. And divide through by 2, square both sides, and square both sides, we have 3x plus 3 all square. At the end of the day, we have v plus 9 equal to 9x squared plus 18x plus 9. 9 cancel 9. At the end of the day, v is 9x squared plus 18x. So you should find v in terms of x. So you can leave the answer like this, or it's still the same thing if you leave it like this. Remember your p1, 9 to bracket x squared plus 2x. Completing the square, this one is x squared plus 2x plus 1 square 1 square. At the end of the day, we have x plus 1 all square minus 1. So v will be 9 to bracket x plus 1 square minus 9. It can also be in this form. That's it. The next question. Find an expression for x in terms of t. An expression for x in terms of t. It's easy to get x once you know v. You know, v is, let's use the normal equation. V is 9x squared plus 18x. And v is dx dt equal to 9x squared plus 18x. You're looking for expression of x, right? In terms of t. So dx will be 9x squared plus 18x dt separate the variable dx over 9x squared plus 18x equal to dt. So from here we have 1 over 9 to bracket x squared plus 2x. Okay, it might not work like this. Let me take it easily. It might not work like this. Let's look at it in this form. Let's look at it like this. Now, so v equal, let's factorize 9 to bracket x squared plus 2x. Let's factorize. And v is the x over the t equal to 9 to bracket x squared plus 2x. So when you cross multiply, the x is 9 to bracket x squared plus 2x. The t, separate the variable here. So at the end of the day, the x over x squared plus 2x equal to 9 dt, which is the same thing as 1 over x into bracket x plus 2 dx equal to 9 dt. Now, from here, that's what I to integrate both sides, but we can simplify this using partial fraction. We can simplify that using partial fraction. As I want to simplify, 1 over x into bracket x plus 2, it will be a over x plus b over x plus 2. At the end of the day, we have 1 equal to a x plus 2 plus bx, when x is minus 2. So 1 equal to minus 2b, your b is minus half. When you substitute it back, you have your a to be half. So a is half, b is minus half. So this is now 1 over 2x minus 1 over 2 into bracket x plus 2. It's x plus 2, right? Equal to 9 dt. Now I've used partial fraction to separate it, to break it down. Let's integrate both sides. So integrating both sides. So this will be 1 over 2 integral 1 over x minus this one too can be 1 over 2 integral of 1 over x plus 2. This one will give us 90 plus arbitrary constant. Let me use k. So from here we have half. When you integrate 1 over x, we have ln x. So when you integrate 1 over x plus 2, differentiation of x plus 2 is 1. So this one will give us ln x plus 2 equal to 90 plus constant. At the end of the day, half is common to be ln x over x plus 2 equal to 90 plus k. Now, going to get the arbitrary constant because the question says we should find it in terms of x in terms of t. So, from earlier on the initial condition, when t is 0 is there in the condition, x is 2. I only need t and x. So I have half ln x is 2. This is 2 over 4 equal to t is 0. 9 times 0 is 0 plus k. At the end of the day, our constant will be half ln 2 over 4 can be 1 over 2, half ln half. So add the constant back. So hence we have our t is 2 in this case. We have half ln so we have half ln x over x plus 2 equal to 90. The k is half ln half, so which can be half ln x plus 2 minus half ln 1 over 2 equal to 90. Half is common, so bring it out. Ln x over x plus 2, right, minus ln half equal to 9 over 90. At the end of the day, multiply both sides by 2. So I use the law of logarithms. So here will give us ln, and suppose it give us ln x over x plus 2 divided by half, that's times 2, equal to 18t. Let me check the space. Okay. So at the end of the day, we have ln 2x over x plus 2, which is equal to 18t. Ln is log base e, so 2x over x plus 2 is e raised to the power 18t. I'm looking for x in terms of t, cross multiply. When you cross multiply, we have x e raised to the power 18t plus 2e raised to the power 18t equal to 2x. Collect the like terms. That will be x e raised to the power 18t minus 2x equal to minus 2e. Oh no, let's do it like this. Let's do it like this. So let's do it like this. 2e raised to the power 18t equal to 2x minus x e raised to the power 18t. So 2e raised to the power 18t, x is common, 2 minus e raised to the power 18t. Make x the subject of formula. That will be 2e raised to the power 18t over 2 minus e raised to the power 18t. That's the answer, x in terms of t. I'm going to stop here by now. I'm a bit tired. I'll do the last section in the morning. Please subscribe to my channel, share. Please, you are welcome free to ask questions. If you're not sure of a particular solution, ask questions. I'm going to explain. You can also email me. I'm available. See you soon.